Hello my dear students. In continuation to the last session, that is discussion on important named reactions, I have covered aldol condensation in that reaction, in that session, right? So now we will be doing the numericals, previous year questions of aldol condensation as well as Cannizzaro reaction. Okay, very important session it is. Just follow the session till the end. You will definitely feel like you have learned many things, many new things regarding this aldol and Cannizzaro reactions. Okay, let's start the session with first question here. This one. So tell me, what is the product found in this reaction? See, we have a carbonyl compound having substrate having two carbonyl groups treated with dilute base and followed by heating in acidic medium. So what is the product formed? Like this they will ask the question. So how can we approach this? So look at here, what are the possible steps we can make here in this reaction? Look, see, dilute base will try to act as a base. Dilute NaOH is there now, so it has two capacities, two types of natures. Either it can act as base or it can be a nucleophile. See, whenever there is a possibility for acid base reaction, so acid base reaction takes place. Okay, remember this first point, very important. Now by considering it as a base, now consider any acidic proton is present in this. Yes, there are acidic protons. Which are acidic protons? See, carbonyl group having alpha carbons. Right now, if any alpha hydrogens are present, those hydrogens are considered as acidic hydrogens, because after removing that hydrogen from, like proton from this alpha position, that can be stabilized by the conjugation of this carbonyl group, conjugation with these carbonyl groups. Okay, so that's why alpha hydrogens of these carbonyl groups are acidic. Okay, so we have to this carbonyl group, this is the alpha position and this one. For this carbonyl group, these are the two alpha positions. So we have some acidic protons that can be removed by this base. Okay, so I am using this dilute base OH minus. Okay, so now which proton has to be removed here? See, by removing we should get a carbon anion. Right now that should be stabilized and that should attack further reaction procedure. Right now, so now if I remove from here, so 1, 2, 3, 4, 5. So this carbon ion after removing proton will get a negative charge on this, that will attack at this 5th position. So that we will get a 5-member cyclic ring. If I remove from here 1, 2, 3, we are getting only 3-member ring now, that is unstable. That's why we need to make a 5-member ring by removing proton from here. If I remove from here, so 1, 2, 3, 4, 5, again same 5-member ring we are getting now. So anyways, you can remove from here or from here, both gives same product, so that we will get a 5-member ring as a product. Okay, so now by removing negative charge, proton from here, we will be having C double bond O. This CH3 group converts into CH2 negative charge on this carbon, and here it will be like this. Right now, now what happens? What are the other steps possible? See, this carbon anion is a nucleophile now, so this can be stabilized by conjugation like this. Okay, so now what are the other procedure? Like what is the forward step here? So 1, 2, 3, 4, 5. So we have a 5-membered carbon here. Why it is attacking there? Because this carbon is electrophilic, because the carbonyl group electrophilic center is created by oxygen pi bond by taking towards oxygen, because oxygen is more electronegative, pi bond is taken towards oxygen only, creates electron deficiency on the carbon. Right now, therefore this carbon anion attacks on that carbon. So what is the ring formed here? So 1, 2, 3, 4, 5. We got a 5-member cycle right now. So write that 5-member ring here. So I am writing here a 5-member ring like this. So now number this as 1, 2, 3, 4, 5. After numbering these, see on second position we have C double bond O, write it C double bond O, and then next on 5th position we have a methyl group, write that methyl group, and this oxygen is converting into the single bond O minus like this, right? We are have this kind of product now. So now this is nothing but upon hydrolysis. So why I am doing hydrolysis? Because this O minus converts into like OH, like hydrogen is taken. Okay, so we will be having CH3 here, OH here. So this is nothing but see to this carbonyl group, this alpha beta. So we got beta hydroxy carbonyl group right now. So these upon treating with acid in dilute in heating condition. So heat this using acid. acid medium. So if you heat this, so what happens? So H plus and OH removed as water right now. So from this alpha position, one hydrogen is removed as proton. So this hydrogen and this OH removed as water, we will be getting alpha beta unsaturated product like this. Okay, this carbonyl group as it is, double bond here, methyl group here. So this will be the final product formed in this reaction. Hope this is clear how this product is formed. Beta, alpha beta unsaturated carbonyl compound. See, within the molecule reaction is taking place now. So you can say this is internal aldol condensation. Hope this is clear. Right now, let us move forward with a few more examples. Yeah. So now tell me, when two different aldehydes upon aldol condensation gives how many products? See, when we treat two aldol like aldehydes or ketones like carbonyl compounds, different carbonyl compounds upon aldol condensation gives how many products? See, they have mentioned what aldehydes or what carbonyl compounds we have to take, they only mentioned in the question. See, this is one type of aldehyde, this is another type, because here alkyl group is R, this is R dash. So I have two different aldehydes. So how many products possible in this reaction? This will be the question. So how can we answer now? See, we know aldol condensation, here it is a cross aldol product, like we can get different types of products. How can we estimate how many products? See, I am saying this as A, substrate A, and this as substrate B. Now what I can say, see, simply when we studied about aldol condensation using this acetaldehyde, so what I told you, so we have to take 2 moles of aldehydes or 2 moles of carbonyl compound, and that should be treated with dilute base, I told you right now. So now what I told you, so this will be from one carbonyl group. So from one carbonyl group oxygen, and from other carbonyl group hydrogens are removed. See, from one carbonyl group oxygen and from other carbonyl group hydrogens together removed as water molecule, so that we will get a alpha beta unsaturated product that I have mentioned it as CH3 CH double bond CH C double bond OH, like this. Now this is the final product formed. Now look at here. Now I have two different aldehydes carbonyl compounds now, both of them having alpha hydrogens, right? So this molecule can react with itself, so that I can get a AA type product. And this molecule can also react with itself, so that I can get a BB type product. Right now, these are the simple aldol condensation products. Now what I am doing is oxygen from this, now I am doing cross reaction. Oxygen from this and alpha hydrogen from this, so that I will get a product like A, B type product right now. In the second case, oxygen from this and alpha hydrogen from this, so I will get a BA type product right now. So total how many products are possible in this reaction? See how many products? 1, 2, 3, 4. So I have 4 different products possible in this reaction. Hope it is clear. So option number C will be our correct answer for this question. Hope explanation is clear with these examples and all, right? Yeah. So you can take this example of cross aldol reaction. What is that? Cross aldol reaction. Okay, let me move forward with one more question from JEE Mains 2021. Okay, see, we have 2 moles of 2 molecules of this cyclopentanone. Upon treating with dilute base, we will get X. Okay, we need to identify what is X, and followed by dehydration gives Y. What is X and Y we need to identify. See, I haven't mentioned any options here. Just give a try. What are the steps I told you? So take 2 moles of this substrate, 1 mole, and next mole also I am taking. 2 moles I have taken. Treat this with dilute base. Okay, dilute base. So what I told you, so oxygen from here and hydrogen from here should be removed, so that we'll get final product. But we want this X also now. So in between that, so when we take this base, so alpha hydrogen from here or from here is removed, so that we'll get a negative charge over here. So this will attacks on this oxygen containing, like carbon containing oxygen, like that, and we will be having a product something like this, O minus. Okay, and this, see, this has attacked over here. So this is what we got. So this what happens, converts into OH. We got a aldol here. Okay, after getting aldol, so what I told you, heat this with acidic medium. So again alpha hydrogen from here, see to this is alpha, this is beta na, so hydroxy group from beta, hydrogen from alpha are removed as water molecule after heating, okay, during heating, so that we will be having a product like this. Like this. So this is our final product. So this is X and this is Y. Hope this is clear how easily we are solving the questions. You don't need to even spend lot of time on solving this kind of questions. Very easy. Just practice few more questions so that it will be comfortable. You will feel comfortable and you can feel approachable. These questions are very easy to approach. Okay, you can save lot of time in the exam if you follow this kind of mnemonics. Okay, so just try to answer this question once again on your own. What are the steps I have included here? Just give a try for the same question and try for new questions. See, new questions means here itself I am mentioning a question for you. See, now what I am doing is, let me take this one, okay, and then next I will be taking one more. From here. So what is a product formed? Okay, again this is cross aldol, but tell me what is a major product formed in this reaction. So I have these two. So what type of product formed? See, when we treat with dilute base, see we know these are acidic hydrogens because electron withdrawing group is present right now. So that will be making this proton to be removed easily. So now carbon ion is generated here, so that will react with this because I have one equivalent this and I have one equivalent this. Now make the reaction and tell me the product. See, this negative charge will be attached over here and generate aldol product, remove hydrogen from here and OH from here as water, will get the final product H plus and heat. Okay, dilute, tell me the product in the comment box. What is the major product formed in this reaction? Okay, very easy question it is. Next, again from JEE Mains 2021, based on aldol condensation only. Yes, so tell me in this case what I can make. Yeah, so tell me anyone from the comment box. Just give a try. See, we have again alcoholic KOH. So where the reaction happens, say we have acidic protons, this is alpha carbon, this is also alpha carbon to this carbonyl group, and this is alpha position. So now we need to remove a proton from most stable site, that should generate a most stable carbon anion, okay, where it will generate, and you know the ring formation step should be also should result a more stable ring, like 5-member ring or 6-member ring. It should not be 3, 4 or 7 like that. Okay, so now if I remove proton from here, if it is attacks here, we will get 1, 2, 3, 4. 4-member ring is highly strained now, so you should not take a acidic proton from here. So if I remove proton from here, this methyl group, see 1, 2, if we generate a carbon ion here by removing proton, so 1, 2, 3, 4, 5, if I attack at this is 6, we will get a 6-member cyclic ring, or if I attacks here, we will get a 6-member cyclic ring. But you know, this is a carbon anion nucleophile, okay, if I generate a carbon anion here, okay, now which is more electron deficient, aldehyde or ketone? See, aldehyde is having something like this, okay, and ketone is having both side alkyl groups. See, we know alkyl groups are electron releasing groups now, so this is less electron deficient, this is more electron deficient. So since it is more electron deficient, aldehydes are more electron deficient, are more electrophilic, therefore nucleophile attacks at this more electrophilic aldehydes only, not ketones. Okay, so when we have a competition between aldehyde and ketone, so you just understand the more electron deficient site and attack the or do the reaction at that electron deficient site. Out of this aldehyde and ketone, I know aldehydes are more electron deficient when we compare with the ketones, therefore reaction takes place at this aldehydic position, it means at this carbon. Okay, that gives us the major product, because in the 4 options you know there will be an option making the reaction is ketone site also, but what I told you, decide the reaction looking at their electron deficiency. Okay, electron deficiency is more at this aldehyde center, so do the reaction at that aldehyde center only. Okay, so now first treat this with base and generate a carbon anion Okay, here I have like this and making a negative charge here by removing this proton from here, and C double bond OH aldehyde here and ketone here. So this negative charge will attacks at this carbon of carbonyl group. Why? Because it is electron deficient, more electron deficient compared to this. Therefore we got a, see, 1 2 3 4 5 6 membered ring. So write that 6 membered ring. What is that 6 membered ring we got here? Carbonyl group as it is, not disturbed here. So write a 6 membered ring like this. Yes. Okay, and after this just start numbering. See, this carbon is numbered as 5 here, and here it is 6, and this will be 4 3 2 and 1. So between 1 and 6 bond formation taking place, and on second carbon we have C double bond O, put that C double bond O, and on fifth carbon, yes, everything is mentioned. So on sixth carbon we have O minus. Right now, is there anything left unwritten? No, everything is mentioned here right now. So next what we need to do, see, this is O minus. So by hydrolysis it will converts into OH. Aldol is formed here right now, OH. Okay, and followed by treating with acid H plus under heating condition. What happens? So to this carbonyl group alpha beta. See, here also you have carbonyl group, but on alpha position you do not have any acidic hydrogen, therefore no reaction at this position, no double bond creation at this. But you know, here you have alpha position hydrogen, so this OH group from beta and hydrogen from alpha, because alpha hydrogen is acidic, are removed as water, and you will be having a product something like this. Like this. So this will be your final product. Hope this is clear how we are making the final products in this given aldol based reactions. Okay, and you can try few more questions even if you are preparing for NEET or JEE. These are very helpful. Okay, see, I am not discussing like silly or basic, very basic questions. I have considered few very conceptual and like stuffed questions only. Okay, you have to practice a very good questions, quality questions, instead of doing some random unnecessary questions. Okay, so to enhance your concepts, try to do like efficient questions. Okay, now tell me, which are the following shows aldol condensation? Out of these options, so tell me how many of them show aldol condensation. So how can you decide this? So in order to show aldol reaction, in order to show aldol reaction, there should be alpha hydrogens now, alpha hydrogens which are acidic, that should be treated with dilute base and gives a product. So now check, is there any alpha hydrogens to this carbonyl group? Yes, alpha hydrogens are there, so this will shows aldol condensation. What about this? See, to this carbonyl group carbon, this is alpha, this is alpha. This side only methyl groups are there, so no alpha hydrogens this side, so no aldol reaction with respect to this carbon. But here you have methyl group now, yes, alpha hydrogens are there, so this will also shows aldol condensation. What about these? See, these are the two alpha positions right now, so no alpha hydrogen on this alpha position, because all of them are covered with what? With methyl groups. It means it has beta hydrogens but not alpha hydrogens. So if no alpha hydrogens, no aldol condensation, so it won't show aldol condensation. C won't show. And what about D? Yes, to these are the two alpha positions to this carbonyl group. So we have alpha hydrogens here, 2 here and 2 here right now, so it will show aldol condensation, right? So A, B, D will show aldol condensation. What about this? So to this carbon alpha alpha, see, we do not have alpha position hydrogens, but we have beta hydrogens, but there is no use of beta hydrogens here as of now, right now. So aldol condensation primary criteria is we should contain alpha hydrogens on the carbonyl group, but there is no alpha, so it won't show the reaction. Okay, now what about this? So this is very important, isopropanaldehyde. So what about this? This side no alpha hydrogen. See, I have told you that C double bond O is there now. there should be a carbon adjacent to this carbonyl group. That carbon is considered as alpha carbon, and hydrogens present on that are called alpha hydrogens. If it is directly attached to the carbonyl, hydrogen directly attached to the carbonyl group is not an alpha hydrogen. This is not alpha. So this is not alpha. So this side it won't show aldol condensation. What about this side? Yes, here out of on this carbon we have two methyl groups. It means we have one hydrogen. This is alpha hydrogen is present, but you know this won't show aldol condensation because this is present in very crowded region, like sterically hindered region it is. Therefore this hydrogen do not taken by base, okay, because it is hindered, it is protected by this methyl groups. Therefore base will not attack or will not take this hydrogens easily. Therefore there is no aldol condensation in this isopropanaldehyde. Okay, remember this, very very important. What about formaldehyde? See, these are not alpha hydrogens, so no alpha hydrogens, no aldol condensation, no aldol condensation. So this is also no. So what are the options? A, B, D are the very suitable answer for this particular question. Hope this is clear. If it is really clear, just click on the like button. Okay, and also you can share with your friends. Okay, if you feel this is really helpful topic and helpful discussion, you just share with your friends so that they can get benefited out of it. Okay, next. Here I have few more things to be discussed. What about Cannizzaro reaction? So Cannizzaro reaction, I have a statement based question on Cannizzaro reaction. I will be going to explain you what exactly Cannizzaro reaction, how it is taking place. Okay, so now look at this. Which are the following statement is are correct about Cannizzaro reactions? In order to answer this, just look at the mechanism which I am going to explain. See, in order to show Cannizzaro reaction, there should not be any alpha hydrogens. In the previous case, aldol means there should be alpha hydrogens. Here should not be any alpha hydrogens. The best example for without alpha hydrogen carbonyl groups is formaldehyde. Okay, there is no alpha hydrogen here. Yes, consider those carbonyl compounds which do not have any alpha hydrogens. Yes, there is no alpha hydrogen. Now treat this with a concentrated base. Okay, there it is dilute, here it is concentrated base, concentrated NaOH or something like that. Now here concentrated NaOH we are taking now. So now there is no acidic proton to remove by this OH minus. So there is no like possibility for showing its basic nature. Right now it can only act as a nucleophile. So OH minus here will not act as a base, it will act as a nucleophile, and where it will attacks at the electron deficient site of this compound. This is the electron deficient site. Okay, because oxygen drags the pi electrons towards it, creates partial positive charge, electron deficiency on the carbon. So therefore this OH minus will attacks here, and we will be getting something like this, O minus H, and this OH minus will attacks here. Okay, like this we got. Okay, now what happens in the second step? See, during the reaction you have to take 2 moles of this formaldehyde. So first mole I have taken, we got a product like this. Okay, so now we have to take 1 more mole or 1 more molecule here, let us say in terms of molecules. Okay, first molecule what happened? So nucleophilic attack taking place, so I can say nucleophilic addition taking place. Now after this reaction will not stop here, so this O minus comes back to its original position. So one of the group from here should be left out from this carbon, because carbon valence is 4 only, it can supposed to have only 4 bonds. Okay, now which is good living group? Either H minus or OH minus. Since the reaction is taking place in a basic medium, OH minus will not comes out because concentration of OH minus is very high. So OH minus is a very bad living group, only H minus comes out. Okay, so H minus comes out from here, and what is the remaining site? C double bond O, OH, right now. So we are getting OH, H minus ion outside, right now. So this H minus ion will attacks on the other carbonyl group. See, I am using this H minus ion. So this will be attacks at this reactive site. Okay, so why it is attacking here? Because there is no other site to react now, only this is an electron deficient site. Since it is having electron rich nucleophile, attacks at this electron deficient carbon, and it converts into what? CH H we have this H minus is attacking here, so like this, and O double bond O becomes O single bond like this, O minus. Okay, something like this. What I can write this? So I can write this as just CH3O minus, methoxide ion we got. Right now alkoxide ion we got. See, this is acid, this is a base. So between them, since the reaction taking place in same vessel, so we will be having this H plus ion is taken by this and it will be converted into CH3OH. Okay, methanol we got, and another one is H double bond O minus and Na plus, carboxylate ion is formed. So in this Cannizzaro reaction, one formaldehyde undergone oxidation forming carboxylic acid and another formaldehyde converts into alcohol. This is what reduction. One is oxidized product, another one is reduced product. Hope both are clear. Now what happens in Cannizzaro reaction? So without alpha hydrogens, carbonyl compounds, see there is no alpha hydrogens, carbonyl compounds, upon treating with concentrated base gives oxidized product and reduced product, carboxylic acid and alcohol as a products. Okay, based on this explanation you have to answer me to the previous questions which I have shown here, which I have shown in this reaction. See, statements, which are the following statements is are correct. Carbonyl compounds without alpha hydrogens shows this reaction. Yes, Cannizzaro reaction is shown only by carbonyl compounds having no alpha hydrogens right now. So it means option 1 is perfect. Next, all carbonyl compounds will show this reaction? No, only those carbonyl compounds which does not contain any alpha hydrogens will show all Cannizzaro reaction. So B is incorrect. Now what about C? H minus, OH minus are the nucleophiles. Yes, I will stand with that statement, that is correct only. See, in the first step OH minus is nucleophile, in the next step H minus ion is a nucleophile. So both are considered to be nucleophiles here. So H minus, OH minus. So it is correct. Okay, what about the other statement? It is an example of redox reaction. Yes, I can also agree with statement 4. So why? Because what are the product formed? Aldehyde, like formaldehyde converted into carboxylic acid, oxidized product, and formaldehyde converted into methanol, alcohol, reduced product. So both oxidation reduction taking place now. So it is an example of redox reactions. So A, C, D are the correct options for this question. Hope this is also clear right now. If it is clear, just click on the like button again. Okay, next. Here, can you do this question? Just use some general, like just small focus on the question will give you the perfect answer. If you are not doing with proper focus, you will definitely end up with wrong answer. See, both compounds have no alpha hydrogen and I am using concentrated base. Now what happens, you tell me? So concentrated base will attacks as a nucleophile. Concentrated NaOH act as a good nucleophile. So where it will attacks? Either like formaldehyde or benzaldehyde. So I told you now this is a nucleophile. So always nucleophiles attacks at the more electron deficient site, more electrophilic sites. So which is more electrophilic? See, benzene, like phenyl group having pi electrons now, so that will also involves in conjugation with this oxygen, like carbon of this carbonyl group. So it means electron deficiency is less here. That will be stabilized by the conjugation. Ring electrons are also given to this carbon, so low electron deficient. Okay, but here when I see only hydrogens are there, there is no groups to donate electrons to this carbonyl carbon, which makes it to be more electron deficient, because oxygen drag the pi electrons to it, creates more electron deficiency here when I compare with this right now. So I can say more electron deficiency is at which carbon? On this formaldehyde carbon. Therefore OH minus attacks at this more electron deficient site. So formaldehyde undergoes oxidation, gives formate ion. So product formed here will be O minus Na plus, like this. Okay, and while doing this reaction, hydride ion comes from here now. So that hydride ion goes and attacks here. Okay, and forms benzyl alcohol like CH2OH product. So this is reduced this is oxidized. So this is A, B you can answer. So they will ask in the question in the exam, like if they will mention B or they will mention A, what is the oxidized and reduced products respectively from the given 4 options. Okay, they will ask like this. Very, very important question. What is a major or the primary step that you need to be focused here? Identifying electron deficient site of the given substrates and doing the reaction or attacking the OH minus or attacking of nucleophile on that more electron deficient carbon gives you the perfect answer. Hope it is clear, right? Yes. Let me go with one more question. Yes. So based on my previous explanation, I want answer for this question. So can you try? Yes. So tell me, it's a concentrated base now. What's happening? So it is a concentrated NaOH means it will be a strong nucleophile. So nucleophile attacks at which groups out of these 2 carbonyl groups? Yeah, where do we have more electron deficiency? We have nitro group, which is strong electron withdrawing group, withdraws electron from ortho, it means ortho positions and para position, but not at the meta position. It means due to the presence of nitro group at para position with respect to this aldehyde, so it creates more electron deficiency on this carbonyl group right now. Therefore, this is more electron deficient. It will be attacked by this OH minus ion first and converts into respect to carboxylic acid. So our product will be something like this, NO2 as it is. So this will be converts into carboxylate ion, O minus Na plus, and this will be hydride ion shifted from here to here now. So this will be converts into alcohol like this. So this will be our perfect answer. So this kind of reactions you will be seeing in JEE Advanced. Just answer me to the other questions which I am going to give you. So what is the product formed in this reaction? This is JEE Mains 2022 question. Okay, so just answer me what is a perfect option for this. Okay, if you want answer, so just give an answer from your side. I will check in the comment box if it is right. Well, if not, I will tell you the perfect answer in the comment box based on your response. Okay, and one more question. Yeah, it's enough. So just give answer for this question. Okay, this is about the session, and you know, if you really like the content, so just share your feedback in the chat box, and also you can share this session, this channel with your friends so that they can get benefited out of it. Thank you for watching. Don't forget to subscribe the channel. Thank you.